Why the dinosaurs are so huge? So there was something I was wondering recently. Then I got this idea. The reason why is that so is because the gravitational force back in Jurassic age is like half of current uh, gravitational force, which made them able to grow very huge, and they don't need to, you know, have the have this constraint, that which is why right now most of the animals are small. But then it hit me that no. But then I spoke to a kid, uh, one of a fresh student in the physics student. We were talking about gravity, and then he was telling me that the mass matter. But then I, the reason why the gravitational force is low is because I thought that Earth was double the size uh, than today. You know, the Earth is not the size as it is today. It used to be, it should be, could be double the size of the planet. You know, it would be double the size of this planet. If today I'm hungry, which is why I'm kind of jumping around my words. So it's possibility, right? You know, the planet could be double. You know, if you ask me the proof and stuff, it'd be very hard because Earth is alive. Itself, Earth core is alive. You know, the air core, Earth core has magma and it's constantly burning. There's possibility there's caveman, which that it will cave in from time to time. So, which is why Earth shrink. On top of that, if it's true that the planet was bombarded by asteroids, you know, that explains, you know, possibility of planet did shrunk. Okay, so that was it. But then when I spoke to him, you know, he was telling me that mass determine the gravitational force, which means that if the planet's size is big, gravitational force is much more stronger. Okay, it's not weaker, but it's more stronger. Means that if today is, I can't remember, it's 9.98 something gravitational force. Today, when the planet is double the size, it could be 20. Okay, I'm just throwing out the figure. I don't know what's that mean. Okay, how many G is that? You know, how many gravitational force? You know, what is the actual reading is it? But I'm just throwing out a figure. So with that, it makes more sense why the animal grow big, because in order to move around with a high gravitational field, you need to have a body mass that is huge. You know, it makes logical sense that in order for you to move a huge planet which have a very strong gravitational force, it makes perfect sense why animals during back days were huge. Okay, which explains why today the biggest animal on planet today, because of the size and gravitational force, is in the sea, because they don't have, you're not able, not required to factor in gravitational force for any motion, you know, for go hunting and if seeking food. While back in days, in order for you to move, you need a lot of energy, and then it's not easy to move. So it's just a theory. Okay, so I hope someone out there going to tell me that I'm wrong and I'm right, wrong or right. I did, after give a thought about it, after the discussion, we did went and search on Google, which seems like smarter than anybody else nowadays. And when I search, the only discussion kind of there was a discussion, similar discussion, where the discussion was the gravitational force during Jurassic age could be lower than today. And that is just why I had the same thought process as well. But then on top addition to that, I thought that the planet size is double than current, which where I kind of, you know, after discussion with the student, I come to the, you know, I kind of changed my thought process that instead of gravitational force is weaker, it is way stronger. Yeah, that's make logical sense for me why animal was so big. Yeah, cool.